about operators in C#. It should be pretty obvious that just storing data in variables would be pointless if we don't apply some form of processing on that data. In the vast majority of cases, even in the smallest programs, you will use at least the most basic mathematical operations such as addition, subtraction, multiplication, or division. All these operations, just like their synonyms in math, are performed using operators. Same as in mathematics, operators take one or more operands and return a value as a result, and they have various degrees of precedence. There are multiple types of operators and they can be categorized in these categories: arithmetic, which performs simple mathematical operations; comparison, used for comparing one or more values or expressions; assignment, which we already learned allow us to assign a value to a variable; binary, used to perform operations on the binary representation of data directly; logical, only used on logical expressions and values; and type conversion, also known as casters, used to convert between a data type and another. Here is a list of these operators grouped by category. As a difference to their mathematical counterpart, the same operators applied to different kind of data will perform different operations, producing different results. We have already seen this in the previous lessons. When we use the plus operator on numerical values, it performed the expected mathematical operation. The same operator used with strings performed the concatenation operation, joining them together. Operator precedence refers to the importance of different operators in relation to each other. If we have an expression containing both an addition and multiplication, which one would be performed first? It is obvious that adding some numbers and then multiplying the result with another number will produce a different result with multiplying the number first, then adding the remaining operand. So, by establishing operators precedence, we enforce laws in regard to which operations are performed before other operations. In cases where we have operations involving operators with same precedence, the operations are executed from left to right. If you want to enforce a different law, you can use parentheses in order to avoid ambiguity, just as in mathematics. Here is a table of the operator precedence, starting from highest to lowest priority. Now, let's enumerate all the operators and analyze their properties and behaviors. Arithmetical operators are the same as the ones in mathematics, with just a few differences. First, if you are using two integers to perform a division, do not expect a real number, rounding, or any fractional parts. If you divide 7 by 3 using integer type, you will get 3 as a result, not 3.5, not 4. If you want to get a correct answer, you should assign the result of the operation to a data type that can store fractional parts, such as double, decimal, or float. Keep in mind too that if at least one of the operands of a mathematical operation is a real number, the result will also be a real number. The next thing to watch out for is division by zero. Since this operation is not valid in mathematics either, it is not valid in programming too. If you try to divide a number by zero, you will get a special kind of error called divide by zero exception. This only applies to integer numbers. For the real types, you are allowed to divide them by 0.0, and you would receive a special kind of result called nan, which is a shortcut for not a number and represents an invalid value. If you want to get the remainder of the division of two integers, use the % sign. This operator will return the remainder of the division of two numbers. For example, 9 divided 2 is 4, remainder 1. Still related to the arithmetic operators, we have the incrementing and decrementing operators. Incrementation is one of the most common operations in programming and basically means adding some value to the value of the operand we are already using. Take this example. We have done nothing else than to assign to our variable the result of adding 1 to its own value, process which is called incrementing by 1. Because incrementation is such an often operation in programming, C#, just like many other programming languages, offers a special operator for it called Incrementing Operator. It comes in two forms. Take a look at the following code. The difference between the first incrementing operator and the second is the fact that the first one will always increment a variable by 1, while the other will increment it by whatever number we specify, like this. The incrementing operators is also categorized into two separate behaviors, distinguished as prefix or postfix. The difference between them is that the fact that the prefix operator will increment the variable first and then use its value. The postfix incrementing operator will first use a variable, then increment it. It may seem like a strange definition, so take a look at this code which explains it better. Now you can see that in the first example, when I used the postfix operator, the program used a variable first, displaying 1, then incremented it, finally displaying 2. On the other hand, when using the prefix incrementing operator, it incremented the variable first, displaying 2, then it used and displayed the variable already incremented. The decrementing operator is similar to the incrementing one in every aspect and forms, except for the fact that it will subtract instead of add the value to the variable. Next in line, logical operators are rather simple, even if they might seem confusing and advanced at first. They only produce two results, either true or false. There are four basic logical operators, also called Boolean operators: and, or, XOR, or exclusive OR, and not or negation. I will show you now what's called a table of truth, which is nothing more than a table showing the results of the logical operations applied on Boolean data. This table may seem complicated at first, with too many things to memorize, but it's actually quite simple. On a closer look, we can summarize that the AND operator will return a true value only when both operands are true and false otherwise. On the other hand, OR will return true if at least one of the operands are true. Finally, XOR will return true only when a single operand is true. It is not hard to notice that the NOT operator simply inverts the initial value. About the concatenating operator, I have already discussed in the previous lessons, and you already know that it is used to concatenate or join two or more strings together, or a string and another data type which can be converted to a string. This type of conversion is made in real time by the net runtime, and it is a very useful feature. However, we will learn at some point that it is better to explicitly convert all the operands in order to avoid implicit conversion errors. This is a sample of using the concatenator operator to merge both two strings and a string with a numerical data type. Bitwise operators are rarely used nowadays. Back in the day when computers had memories consisting of only kilobytes or megabytes at best, programmers really had to struggle to get out of every piece of efficiency out of their programs with the least occupied memory. This often involved manipulating the memory directly, and bitwise operators were often used for this. You already know that, for instance, number 55 is represented in memory as a series of zeros and ones, or more to the point, a series of 16 binary values. Since the binary language only contains two values, 0 and 1, bitwise operators, which allow us to perform operations on the binary representation of the data directly, can be somehow associated with the logical operators, which also operate with only two values. Thus, the bitwise operator also contains a table of truth. There are 6 bitwise operators, of which 4 are similar to the Boolean ones, AND, OR, XOR, and NOT. The table of truth is similar to the one of the logical operators, with the difference that 1 represents true, while 0 represents false. There are 2 additional bitwise operators that the logical ones don't have, and they are bit shift left and bit shift right. On numerical values, this operator moves the bits of the value to the left or right, and you should remember that the bits that fall outside the number are lost forever and replaced by 0. Here is an example of using the bit shift left operator. The way we use it was by placing the value we want to act upon first, followed by the bit shift operator, and the numerical value that indicates by how many places we want to shift the bits, like an offset. That also means that we want to move the bits of the number 3 to the left twice. Looking at the decimal binary table, we see number 3 represented like this in binary. After we perform the bit shift operation, the binary representation will be like this because we moved the bits to the left by 2 places. The same table tells us that the resulting value is now 12 in decimal. I did say that the bits that fall outside of the number are forever lost, and we only need a single example to illustrate this. If we perform a bit shift right operation on the same number 3 by an offset of 1, the resulting binary value will be this one, which is 1 in decimal. It is pretty obvious that we lost a significant bit because if we try to bit shift left by 1 place again, the resulting value will not contain the one that was lost during the right shifting. Anyway, like I said, bit shifting is extremely rarely used today. Comparison operators, like in math, are only used to, well, compare two numbers. They are greater than, lower than, greater or equal to, less or equal to, equality, and difference. They all produce a Boolean result, meaning a true or false value. This is only logical. A number can either be equal to another one or not. Assignment operator was already discussed in detail in the previous videos, so it is not the case to insist on it. It only gives or assigns value to a variable. The conditional operator is probably a bit harder to explain because it is based on things we haven't learned yet. It always takes an operand, an expression that produces a true or false Boolean result, and returns one value or another depending on the result of that expression. It is also known as a ternary operator because it involves 3 operands. The question mark sign is placed between the first and the second operands, while the colon character is placed between the second and the third. It will be best to understand it if I give you an actual example. What we did was to declare two integer variables and then use them in a logical expression, checking if x was greater than y. If that expression produced a true result, we display this value, otherwise we would have displayed the second one. One final note related to this operator is that we can also use it with assignment. This means that we can assign either a value or another based on some condition. At the end of this lesson, I should tell you that there are a number of other operators that are either too simple, too rarely used, or too unimportant to talk about it. The dot operator is used to access properties, methods, or fields of classes or objects. We don't know what these are yet, but we will learn about them in future lessons. Square brackets operator is used to access elements of arrays. Again, we will learn about arrays in the future. The round brackets operator is used either to specify a different order of operations to define the parameter list of a method or to call it. Operator new is used to create instances of new objects or in common English copies of it. Operator is used to check if an object is compatible with a certain type or not, in order to check that object's type. Operator as is used for time conversion, returning null in case of invalid conversion. In the next lesson, we are going to talk about casting, implicit and explicit type conversion and others. See you!